This video is going to cover the three more basic ways of changing between forms of quadratic functions. When we've talked about parabolas, we've talked about factored form, standard form, and vertex form. And so this lesson is going to go through how to change some of those forms. But this video is only going to cover page 4, that is the first page of this lesson. There will be a separate video for the second page, which is the more difficult concepts. On this page, we're just talking about how to change from the three kind of easier types. So first of all, from factored form to standard form. Here we have a factored form of a quadratic. We've been working with how to multiply these out. One thing I might talk to you about in the beginning is that -2 only gets distributed once. And since it only gets distributed once, I like to save that for the last part because that way you don't accidentally distribute it twice. Okay, so let me show you. I'm going to save my -2 out here, and then I'm going to multiply the other two binomials. Okay, so first I multiply that double distributing, just the binomials, and I get -2 times x squared minus 2x minus 3. Now I'm going to go ahead and distribute that -2. And so that's going to give me -2x squared plus 4x plus 6. A couple things about each form is we've talked a little bit about why each form would be helpful. And so one of the things that's helpful about factored form is that factored form gives us the x-intercepts. So here I have my factored form. That 1 means that I have an intercept at -1. This 3 means I have an x-intercept at +3. Now, what I do next is I find my axis of symmetry, and my axis of symmetry is when I average those two numbers, my -1 and my 3. I average those together, and that comes out to be +1. The other way is just to count on your graph and get to the middle. Let me explain this table of values down here. It looks a little bit different than what you're used to seeing. This is just a table that we can use to plug in. So this middle section here is just the section where you can plug in the numbers. So I want that because I'm going to plug in a +1. That came out to be a +1. That's an equal sign. +1. So if I plug in a +1, I can plug it into my original equation or my new equation. I'd like to go back to the original. I just think that's a safer way to do it. So I get -2 times 2 times -2. A negative times a negative is a positive, so that looks like a +8. I'm going to go in and graph my vertex at 1, 8. Now, because of that -2, we've learned our 2, 6, 10 rule. That is, we take 1, 3, 5, and we multiply it by -2. And that gives us -2, -6, -10. So I'm going to go down 2 units, and then I'm going to go down 6 units, and then I can go down 10 units. And that's going to be my parabola. If I needed other points, I can plug those into my table also. But that is going from factored to standard. The next example goes from standard form to factored form. Okay, well, again, we've talked about each of the different benefits of each. One thing I know from standard form right off the bat is that the y-intercept is at 0, 6. I might just plot that just so I have it. It helps to have it. If I need to go to factored form, I want to take this and factor it, and it looks like the first thing I could do is divide out a 2. Now, I've said in previous videos that the reason you can do that, the 2, all it affects is the stretch, the vertical stretch. It doesn't really affect anything else. And so I should be able to do this and factor out my +2. So I divide out my 2 and I have this trinomial. I need to factor this because 3 plus 1 is 4, 3 times 1 is 3, so I know this is the correct factorization. I need to bring down that 2. Don't forget about that 2. Now, when I go to graph it, I know I have a x-intercept at -3 and another x-intercept at -1. My axis of symmetry is at -2. So that's going to give me my vertex eventually. So now I'm going to plug in. I like to plug into the original equation. And when you plug in, I like to plug in with using parentheses to make sure you keep all of the signs and everything. So -2 squared, that's +4 times 2 is 8. 8 minus 16 is a -8, plus 6 is -2. So my vertex is at -2, -2. Now, because I have a leading coefficient of 2, I'm just going to follow my same rule I had before, 2, 6, 10. So go up 2, go up 6, and that's where my y-intercept was. And that's just kind of a nice thing that is almost like a double check, that you did it through the y-intercept here, and then as you counted, turns out it worked out. Notice it is the 6. I factored out the 2. It's not 3, it's the 6. And then I would go up 10 after that, which I don't have space to do. All right, so when we graph that, it's going to look something like that. Mine's a little bit messy. I'm having a hard time with my board today. So that is the parabola. Mainly the idea was going from standard form to factored form, and so we did it. The last form that we have is from vertex form to standard form. So again, here is a special case. We've talked about special cases, and so we basically need to multiply x minus 4 times x minus 4. So let's do that. So when we multiply that out, we get 1/2 of x squared minus 8x plus 16. We're looking for standard form, so let's go ahead and distribute that 1/2 back in. And so what I get is 1/2 x squared minus 4x plus 8. We have a couple things that we can notice. One thing is, remember, if there's nothing added on here at the end, we need to go ahead and put that plus 0 on there. So our vertex, according to this, our vertex is at 4, 0. Then this is telling us that we have a y-intercept at 0, 8. The 1/2 is telling us that instead of 1, 3, 5, we need to go 1/2, 3/2, 5/2. So from my vertex, you know what, I'm going to go ahead and draw my axis of symmetry while I'm at it. Okay, from my vertex, I'm going to go up 1/2 and over 1, which is kind of hard to do on this graph paper. We're just going to have to kind of estimate. And then up 3/2, which is like 1 1/2 over 1. I'm going to go ahead and make my reflection up here because I could continue going, but I think I've got enough now. So this is going to give me my parabola. And so my parabola is going to look something like this. Just another comment on the XY table. Again, you don't need this middle part. If you don't want to use the middle part, you don't have to. But you can always go back to an XY table. That if you want to plug anything in, you could plug in, since this has a 1/2 in front, let's maybe stick with even numbers. So let's say we stick in a 0 and a 2 and a 4. Okay, we can plug those in and we can still use a table of values. You can always use a table of values. So that's 1/2 of, and we're going to square -4, that's 16, so that's going to be 8. And that's where our 0, 8 is. If I plug in a 2, that's a -2, squared is 4, half of that is 2. So we have a point at 2, 2, and look, we do have a point there. And if I plug in a 4, that's going to give me 0. And so I want to look on my graph. Oh, look, there it is at 4, 0. So I have this table here just to remind us we can always go back to a table of values if we need to. Okay, this page covered the 3 easier conversions, going from factored to standard, standard to factored, and also vertex to standard form. We'll stop this video here, and then on the next video we will cover the other third way, which is changing from standard to vertex.